Hello friends, this video on aldehyde ketones and carboxylic acid part 11 is brought to you by examfear.com. No more fear from exam. Now we'll learn some methods to prepare ketone exclusively. We'll learn three methods. One is from the acyl chlorides, from the nitrile, and then from the benzene and substituted benzene. Let's discuss preparation of ketones exclusively. There are three methods actually, from acyl chloride, from nitriles, and from benzene and substituted benzene. Let's discuss from the acyl chloride. See, from acyl chloride, what we do is, if we have acyl chloride, we use CdR2, CD2 plus R minus I minus. This is my CdR2 dialkyl cadmium, and with this I get ketone, and I get CdCl2. So what is special about CdR2, this dialkyl cadmium? This is similar to RMGX. If you see RMGX, it has R minus Mg2 plus X minus. This is RMGX. If you take CdR2, this is CD2 plus. Here you have R minus, here you have R minus. Correct? But since in cadmium the shielding effect is less, this is tightly held, so this is less reactive, and this is more reactive. So why are we not using RMGX? Because if I use RMG's Grignard reagent, so it will further reduce this ketone to alcohols. So we don't want that, right? So we'll use CdR2. It's less reactive than RMGX. And how to form CdR2? See, CdR2 we can form by, okay, I'll take that later. Let's see the reaction first. Let's assume that you have CdR2, right? So if I have acyl chloride and I have CdR2, so if you see here, this is oxygen slightly negative charge, slightly positive charge. Chlorine hogs electron from this carbon, it develops all the more positive charge. So if you see, this carbon has very much positive charge, but if you see the ketone, right, so this gets slightly negative charge, gets slightly positive charge, but this alkyl group gives electrons to this carbon, so this has less positive charge. This has all the more positive charge. So if you see, there's a very strong, you can say, nucleophilic center, or it is a very strong electrophile. It's very strong electrophile. And if you see, this is R minus and plus 2, this R minus can easily attack this. But this R minus is not that strong to attack this carbon. Right? That's why we are using the mild agent. So please note, as I told, in case of aldehyde and ketone, we always look for mild agent. DIABL4, the DIABL is the mild agent. Here, CdR2 is the mild agent. If you compare RMGX and CdR2, CdR2 is a mild agent. Correct? So if we are using CdR2, and with this you get this and CdCl2. Correct? That is the reaction mechanism. And now, once you get this, even if you add CdR here, this won't go anywhere. There won't be any reaction because this is a mild agent. It won't be converting ketones to alcohols. But instead of this, if you had used RMGX, Grignard reagent, it would have converted ketones to alcohols. Correct? And that is the reason why we use CdR2. So to prepare CdR2, what we do is, we take this RMGX, again Grignard reagent, and we react with CdCl2, right? Cadmium, dichlorocadmium, and I get CdR2, that is dialkyl cadmium, plus 2 charge, minus 1, minus 1. So this is the reaction mechanism. Let's now discuss ways to prepare ketones from nitriles. To do this, what we do is we take nitrile and we take Grignard reagent here. And whatever product we get from this, right, let's suppose we got X product, we do a hydrolysis. And then we get ketone. For example, if I have, let's suppose CH3, CH2, C triple bond, and this is my nitrile. And let me add a Grignard reagent, that is C6H5 MgBr, let's suppose. Correct? Now with this, what happens is this bond breaks. Since nitrogen is more electronegative, it gets a negative charge, slightly positive charge. In this case, my alkyl group, that is C6H5, has a negative charge, Mg has plus charge, Br also has a negative charge. That's how the Grignard reagent is. So this C6H5 will be attached to this carbon, and this whole MgBr will be attached to this nitrogen. Correct? So we have seen these kind of examples. This becomes C3H2, C double bond N, and here I'll have phenol, and here I'll have MgBr. Correct? So now here also, if you see, nitrogen will have lone pair of electrons. Correct? Now what will happen is, we are doing a hydrolysis. So when you do hydrolysis, you have H plus OH minus ions. So H plus, and let's suppose we have OH minus ions from hydrolysis. So this lone pair of electrons will attract this H plus, and this OH minus, since this Mg has plus charge, as I told, right? Mg has plus charge. This will get attracted to Mg, and this bond will break. So with this, what you get is CH3, CH2, C, PH, N with the H, and you get MgBr with OH. That's what you get. And again, here also, if you see, there's a double bond here, nitrogen will still have the lone pairs. Again, you do hydrolysis, you have H plus and OH minus. So you have H plus and OH minus again coming. So here again, nitrogen will attract this H plus. Correct? This bond will break. If you see, nitrogen is more electronegative here, right? So carbon will also get slightly positive charge. See, here also carbon has slightly positive charge, but Mg has more positive charge. So OH minus got attracted to Mg plus. Here carbon also will have slightly positive charge, right? Because nitrogen is more electronegative. So OH minus in this case will be attracted towards this carbon. And again, this bond will break. Correct? This bond will break in this fashion. So what you get here is, draw here, CH3, CH2 will be intact, and C with a single bond N, and here I'll have OH, here I'll have phenyl, and here I'll have lone pair of electrons. That's what I'll get. CH, this H attached to N, so N has two hydrogens now. Correct? So since I'm doing hydrolysis, I will have more H plus ions here. Correct? So this H plus ions will be attracted where? So one option is oxygen attracts H plus, or one option is nitrogen attracts H plus. So nitrogen will attract this H plus, because NH3 comes out very easily, right? We have seen a lot of cases. So this becomes CH3, CH2, C, OH, PH, N, H3, and N with the plus charge, right? Now here, nitrogen with the plus charge, nitrogen won't like it, because nitrogen is electronegative compound element actually. So this bond will break now. This bond will break in this fashion, so that this electron comes to nitrogen, nitrogen becomes neutrals, and this becomes positive charge. So this becomes CH3, CH2, C, OH, pH with the positive charge because this bond broke, and plus NH3. This goes off. Correct. Now this carbon has a positive charge, so either it should get some negative charge element, but there is no negative charge element. So what happens is this hydrogen will say, okay, I will leave to make this neutral. So this hydrogen bond will break in this fashion. With this, oxygen will get a negative charge, and negative and positive charge will form a double bond. So with this, what you get is CH3, CH2, C double bond O, and pH, and H plus goes in the system. That is a reaction mechanism for this reaction. So hope you understood what happened here. I had this nitrile. Let me explain once again the different color. So I had this nitrile, the triple bond, nitrogen being more electronegative than carbon will slightly have negative charge, carbon will have slightly positive charge, and I have this Grignard region. We know in Grignard region Mg has +2 charge. This alkyl group, in this case I have a benzene ring, will have a negative charge, and Br also will have negative charge, right? So this negative charge will get attracted toward this positive carbon, and this Mg plus MgBr, the whole thing will have negative charge. Whole, if you see, this will get attracted towards nitrogen. It forms this compound where this one of the bond will break, it form a double bond, right? And now if you see here, again I'm doing a hydrolysis. Next step, this is step 2. From here, this is all step 2. It's all hydrolysis steps. So H plus and OH minus here comes. So H plus will look for lone pair. So the only thing which has lone pair is a nitrogen, and OH minus will look for something which has plus charge. So Mgb has maximum plus charge. So OH minus will attract to Mg plus, and H plus will be attracted towards nitrogen lone pair. So this bond will break. So MgBrOH will come out and will have this compound. Again, we'll do more hydrolysis, more and more H plus OH minus will come into the system. Now again H plus and OH minus ion. So H plus, if you see, the nitrogen again has the lone pair. So this hydrogen will be attracted to this nitrogen, and if you see this nitrogen is more electronegative than carbon. Carbon will develop slightly positive charge. Since carbon has slightly positive charge, OH minus will be attracted toward this carbon. Again, this double bond will break and will have a single bond here. If you see, there's a double bond here. Now we have a single bond here. Correct? This bond will break in this fashion, and hydrogen will be attached to this nitrogen, and OH will be attached to this. Again, we'll have more H plus ions in the system. This H plus ions will again look for a lone pair. Nitrogen has, oxygen has. It will get attached to nitrogen, because again there is a possibility that if it becomes NH3, it can leave easily. NH3 is a good leaving group. It's more stable also. So H plus will attach to this NH2. It becomes NH3 plus, but nitrogen doesn't like positive charge. So this is electronegative element. It will come out, and this bond will break in this fashion. So electrons will go to this nitrogen. Nitrogen will become neutralized, and carbon will get a positive charge. Since carbon gets a positive charge, it has to be neutralized, but there is nothing to deneutralize it. So this hydrogen will say, okay, let me go off, and it becomes a double bond. Or if you want, you can think in this fashion also. This is the positive charge. OH minus comes in a dash here. There is a 2 OH minus in this carbon, and we have seen a lot of places that if in one carbon you have 2 OH minus, 2 bulky group, H2O goes off and oxygen is left with a double bond. So you can think in this fashion also, right? So that is the reaction mechanism for this reaction. Let's see this reaction where we have to prepare ketones from benzene and substituted benzene. So here if you take a benzene, and what we can do is we can take some acid chloride, and we can use AlCl3. It will be a Friedel-Crafts reaction. You will get ketone. This is nothing but my Friedel-Crafts reaction. We have seen this reaction a couple of times. I'll show you one example, or instead of AlCl3, it is something like Ar or RCOCl. That is my acid chloride, right? And you get ketone. Ketone will be something of this fashion. Here, Ar or R. one example I can take. For example, I have this benzene, and I have CH3COCl, and I'll use AlCl3. So I'll get this compound. So the reaction mechanism is pretty simple. So AlCl3 will react with CH3COCl to give AlCl4 minus and CH3CO carbocation. Now I have my benzene ring and I get this carbocation with the positive charge. This double bond will attract this positive charge. Double bond will break, and even this has hydrogen by default. Each of these has hydrogen, but I'm not showing it. I'm showing only this because this will take part in this reaction. So with this, what happens is this bond breaks, right? This bond breaks, and this comes here, and it gets a positive charge here. Since the ring has broken and the aromaticity has gone, to restore it aromaticity, what happens is this H plus goes off and it gets a negative charge here, and again the bond comes up. So this bond breaks in this fashion. So with this, you get this. We have seen this reaction a couple of times. This is Friedel-Crafts reaction. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.